Okay. Now we've already talked about this pendulum, no drag. Now, everybody knows this from physics, but that's the model. Anybody's listening that doesn't know the physics, look it up. Just basic harmonic motion. Okay? Of course, that could also be written and we could solve it this way. Okay? The solution. Two parameters, A and omega, A and phi. Okay? Omega is square root of K over M, which is G over L since K is mg over L. So K over M, the M is going to go away. Okay? So that's something we know. Okay? Now with drag, probably going to use the wrong symbol here because usually there's a symbol we use when the drag is proportional to the velocity, and another symbol if it's proportional to the squared velocity. Okay? That is, it's proportional to V, which is of course x prime, right? And it makes sense, the faster something is moving through the air, or water, you know, whatever the pendulum's oscillating in, the more force, drag force, and the force is going to be in the direction opposite the motion, opposite the direction of motion. Then, and I should have included m here because this is the force, right? Mass times acceleration. So we have that here also, right? Well, there's our differential equation, right? How do we solve this equation? Second order equation, coefficients are constant. Reflex. Actually, I used lambda here. Probably should have used R because that's what we've been using, right? We've done this. So that's totally familiar. So you have this, right? I mean, if you plug this in here, everything, the A's cancel out, the E to the RT's cancel out, or divide out of the equation. I don't like that word cancel. Okay, but you guys are old enough to use it. Okay. Pre-calculus students aren't, they'll cross anything out with anything. It looks similar. So I forbid it in that class. I usually don't like to use it anywhere. But at some point it does become a useful term. I'll kind of assume you guys are there. Okay, let's make sure my R looks different than my gamma. So what's the solution here? R equals what? Yeah, just what you were thinking, negative gamma over m plus or minus the square root of gamma squared over m squared minus 4k over m, all divided by 2. And what's the nature of this solution?
Quadratic formula.
Well, yeah, it came out of the quadratic formula. We're done with that. There it is. What's the nature? Now, actually, there are simplifications that we want to do. We're going to factor out reciprocal m here, actually. Get that in the denominator and then deal with these. So we're going to end up with a gamma squared minus 4km under the radical. And just a negative gamma here. But we're short on time. We're not going to do that right now. I just want to establish that there are different solutions here, okay? Large K compared to gamma. If K is big, in some sense compared to gamma or whatever multiple gamma, right? Or if 4km is bigger than gamma squared, then this discriminant is going to be negative. You're going to get two complex solutions. What if gamma is large?
You'll get two real.
Yeah, two real solutions. Okay? And the other thing is that as long as k is not 0, then this square root is less than gamma over m. Because the square root of gamma squared over m squared is gamma over m. Something I want you to think about. Just I'm doing this at the end doesn't mean you don't want to think about it. Because if you think about it, it'll be out of your way when you've got to interpret these things a little more rigorously, okay? So we should see that since this is negative, this is going to be less than the square of gamma over m, which means that the square root is going to be less than gamma over m, which means we get two negative solutions. Okay? So it's two negative solutions, which gives you two decreasing exponential functions. Because of course your exponential function, whereas it is here, right? So far as negative, you got a decreasing exponential function like the one I drew before. But there are two of them. Okay? One of them with a much quicker decrease because you're going to have a negative gamma over m minus something that might be close to gamma over m, right? And one less steep. So one more gradual, one less gradual. And you're going to do a linear combination of those. And there's also the case where this is equal to 0, which is actually kind of an easy case to deal with these guys. Plain old one exponential function, just one decline. Okay? Just exponentially slumps back to 0 like a pendulum in molasses. Okay?